Good morning, sir. This is Anusha Tribute Department A section. My topic is applications of GLS and compare the cost of ALS and GLS. And our overviews of generalized least square GLS. GLS means ALS means alternating least square. Introduction. This representation compares the applications of generalized least square with alternating least squares and examines the cost of efficiency of these methods in different concepts. Overviews of GLS. Definition. GLS is a statistical method that generalizes ordinary least squared, the allowing for heterostatically and autocorrection in the error terms. Applications of GLS. Econometrics, time series analysis, panel data model. First, econometrics used in projection models where the error terms are not homostatic or exhibits autocorrectional. Time series analysis used in financial model for economic forecasting where autocorrection is present in the data. Panel data models effective for model with cross section and time series data correction or serial correction. Overviews of ALS. ALS is an optimization technique used to factorize matrix, commonly used in collaborative filtering matrix and machine learning. Applications of ALS: collaborative filtering, matrix for factorization, machine learning. First, collaborative filtration used in recommender system to predict ratings based in user interaction. Help in decomposing material matrix into latent factor for pattern recognition. Machine learning applied in various machine learning models, particularly in the area of unsurvived learning. Comparison of ALS and GLS. Features ALS and GLS. Primary use: recorrection with autocorrectional errors. Matrix factorization in recommender system. Assumptions: required modeling or error structure. Requires an initial guesses and array to models. Computation complex. Higher due to convection matrix estimation. Iterative may coverage slowly for large. Cost comparison GLS versus ALS. Comparison time. ALS require inversion of the error convention matrix which can be computationally excessive for large detectives. ALS iterative operates may require multiple passes over the dataset, potentially slow for large materials. Model complexity. GLS required correct specification of the error structure which can add complexity. ALS need initial guesses for matrix factors and the coverage rate may depends on the initial choice. Accuracy versus efficiency. GLS more accurate if the error structure is well understood but computationally expensive. ALS can be more efficient for large data sets but may statistics accuracy without proper regulation. Advantage and disadvantage of GLS. Advantage: provides more effective estimate when the assumption of homo academic and autocorrection and violated. Correction for issue the OLS cannot handle. Disadvantage. Required knowledge of error coverage matrix. Computationally more demanding that OLS. Disadvantage of ALS and GLS. Advantage. Suitable for large sparse data sets, common in recommendation system. Flexible and adaptable for various missions, learn tasks. Disadvantage. Can be slow to coverage for large data sets for properly choosing initial factors. Performance highly depends on higher parameters and collaboratives. Conclusion. GLS is highly efficient for correcting heterodynamic and autocorrection and rejection models, making it ideal for econometrics and time series analysis. ALS is effective for large-scale data matrix factorization tasks commonly used in recommender system and mission learning. The choice between GLS and ALS depends on the problem at hand. GLS is perfected for statistical modeling and econometrics, while ALS excludes in collaborative filtering and metrics. Thank you, sir. My topic is over.